Anyways, today I'm going to be going over the network protocol API. Basically, the network API, the network stack is what we need and how the computer can talk to other computers. Essentially, they are a protocol that the computer must follow and be able to talk to each other. This is really how they talk, how they communicate. This is a very, I wouldn't say it's a very complex or complicated system to understand, but I will say that it is something that is quite difficult to comprehend given the time constraints, in particular because I am a student and I'm about to take the exam. But slow is fast and fast is slow, and that is basically my attitude in approaching this particular problem. So let me just pull up all the resources that I have. What I usually do is I get everything down on my workstation, all set and ready. Very important. We need that to basically get our work started. Is we need all these items available. Get all our workstation ready for this, what I call the sawdust therapy that we're going to look at. By the way, I consider this a not studying, not homework. I consider this a sort of a dialogue. We are talking about a subject. We are talking about life, and love, and the reason why all these things came about is, I believe, the root is the philosophy. It started with philosophy, and that consists of curiosity. It consists of asking questions, and that's how we learn, man. I believe that it's through philosophy that we learn. And this is just this is a lot of data to comprehend. There's really very little time to look at here. I just want to make sure I'm in the right track, but we still have to get started somewhere, and it's very important that we just get this show starting. Let me check, make sure my audio is working. Alright, it's working, but I just had trouble with the music. Alright. Alright, so basically we're going to go over this. Let me download this file. This is going to be overview lecture for computer networking. Let's see. Alright, so let me pull up all these files that I need so that I can okay, cool. Nice, the restore function on Google Chrome actually brought this up. This is the slide for the computer networking. I'm going to go over the basically the architecture of the internet. Basically, computer networking or the internet. I guess they go hand in hand. I'm just going to go through all these things and basically let me just fix this a little bit. Wireshark is a very awesome program to examine. Basically, so I kind of went over. But basically, this is the internet. This is the protocol view. This is the construct of. Let's see here. This is the. This is the basically what it looks like, the internet. We start with different layers. It's hierarchical in its nature. I have trouble pronouncing that word, but we are here to learn. So let me just look it up, because I have trouble pronouncing this particular word.
Hierarchical.
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 Hierarchical. It's a weird word, man. It just sounds weird to me. Hierarchical. But here we have the application is basically the software that runs on the computer, and it will utilize the transport protocol, and after that is your network protocol. Then you have your link, which is the link layer, and then you have the physical layer. We need to define all these layers. Let me just get a pen and write this stuff down. We have to sort of digest these different layers of the internet. To be honest with you, I would rather be playing a game right now than an application. Network stack. We have the application, we have the transport. Have the network, we have the link, then we have physical. So we have the network, we have the application, we have the transport. I believe the transport deals with the TCP and the IP addressing. I think network is IP. And you have your. It's weird. I don't know why it shows it like that. It should be something else, honestly. Talked about what a protocol is in my last video when I covered network performance. Basically, this is what the internet composed of. You have the host and you have the link that connects to the router and sends packets through the router into the other computer. Computer talks using packets, which is this little bytes of data. This bytes or bits. Uses a method called packet switching, and it knows where to send its address using a forwarding table or packet forwarding. Looks like. So if we look here, we can kind of see what we're looking at here. So your transport would be your TCP UDP. The application is obviously the software, and then we have the network, which is Wi-Fi or Ethernet. Oh, I'm sorry, that's the link. My bad. Link could be your Wi-Fi, it could be your Ethernet. And I believe network, I think transport and network is on the same level. I don't know why they have it like that. So we have the application. Let's see. Transport, network. So network is your IP. Oh yeah, so you have your network as your IP. and then you have your link, then you have your physical. And they say here that the host runs all 5 layers of the protocol stack, and the router. I'm actually take out of that. Note that the router only runs 3 layers, and that would be your. Oh, that's why I used to check the one. Should be the red. Is it the red or the orange one? Not sure. Basically, it uses the network, and it uses the link, and then you have the physical. So it only runs on 3 layers of these protocols that they use. Wow, there's an hourglass model. So there's the IP address is your single common language, and then it splits off to 2. If you're using voice or DNS, it goes through UDP and then TCP, web and Netflix. So here's some definition. So the link is the medium over which nodes can communicate at the link layer without using IP. We know what an IP packet is, a sequence of bytes with an IP header. Just a couple of stuff. Multiplexing, concurrent transmission of messages, recovering per application message, encapsulation, add protocol header to any message, to a message at any layer of the protocol stack, and remove the protocol header of a message at any layer of the protocol stack. Multiplexing, demultiplexing. Those are technology. Multiplexing, demultiplexing in simple terms is basically multiplexing. You are about to transmit something, but you need to sort of compress it into either a packet or some form where you can send it through a medium properly, and then demultiplexing is just decoding that message when it receives it. This is used in radio and a lot of communication. Anytime there's communication networking involved, whatever it may be, there's some multiplexing and demultiplexing procedures that has to be done. Datagram deals with the UDP transport layer, and a message is a transmission unit, a sequence of bytes sent and received by the application. Nice, cool beans. And then we talk about here they talk about. Anyways, we have to go over this a little bit more, and I'm gonna go ahead and open another book that I have here to quickly deduce or get more information. I love getting 2 books. I always have 2 books on hand to compare data. By the way, all these books that I get are free on the internet. Old editions, they're very outdated versions, but they teach the same principles, because that's what they teach the basic simple principles of everything. That I am opposed to people buying college books. I don't recommend anybody buying. I've never, if it's $40, $30, I'll buy the book. That's what I do. I buy old editions. There'll be new things that I'll probably miss out, but generally, with a time constraint, you only have 1 semester to cover a class. With that constraint, there's no way you can cover new materials. You still have to go through the fundamentals. Why would you buy a college book? I don't buy college books. I never will. No. You get the old editions, you learn the fundamentals, and if you need to increment that knowledge, then you do your research or whatever. But I oppose and will not pay more than $100 for a book. Not even 50. This is ridiculous. This is yes, you have to. Yes, children have to be fed. I understand. There are families there that needs to be fed. But some people just cannot afford that much. I mean, but the goal here is to learn and not be hassled, not be scammed, not be, you know, these mafias, you know. They don't have guns, they don't dress, these mafias, they dress like they're sheep's clothing, pretty much. They take all your money. I will never buy a book. I don't understand. You learn the basic concepts, the basic principles. It doesn't change, it can't change. This is what people do. They get the raw chicken and they marinate it. And you get marinated chicken and they just charge you more for it. No. I buy the raw chicken and I do whatever I want to do with the raw chicken. I beat it, fry it, saute it, and I do that. I don't need to know about it. Some people, yes. If you want that, the extra stuff, then yeah, go ahead and pay for it. But I personally will not pay $200 for a college book who has more pictures or has more stuff on, more content on that shit. No, I'm not. All right, let's continue with the with all this with the basics here, and plus with the book they come with, you know, PowerPoints. I mean, this is why they want the Net Neutrality Act, I believe. I haven't looked into it, but they seem to want to pass that law, and basically they want you to go back to the Stone Age, because if you do not know, if you do not have the capability to get information, you are not able to get knowledge, you might not be able to have wisdom as well, and you will become a slave to the system. The system will enslave you. That's their goal. That's what the people who thinks they know it all, to basically, if they can get information out, knowledge or whatever that can enlighten you, that make you believe that there's no value to it, and it's just a lot of stuff. Anyways, but I'm just glad that at this moment in time we have access to information. If you want to pay for it, then hell yeah. There's documentaries. I forgot the name of that one documentary, but there's a new website that came out. They're documentaries and they charge people for it. But you know, you do what you want to do with your money. But my goal is to eat, pay for shelter, and learn. But I will not invest in a book. I will, but I can. I don't know. People do their own thing, you know. It takes time to figure it out. It takes time. Let me look at what we have here. We were talking about the protocol layer. I wrote them down. Oh, I was gonna open a book, basically to learn a little bit more. I just need to figure out where that book is. Alright, so it's one of the books. Again, old edition, very old. What is it, 6th edition? Let's see. Socket programming with UDP. Holy shit. I did not know they had this on here. Oh, that's unreal. Oh, look at that. They sent the message. The message was a raw input. Oh my god. You see, this is why I'm so mad, because I was doing a socket API with Java and I could not decode the message that was being sent. Because for some reason the message that I was trying to get here, I was not able to decode it. Anyways, that's something else. I'm going to go ahead and look at, okay, there's different layers here. The application layer we have, so this goes really in depth of what we have. We have the application layer, we have, no, network edge, network core, protocol layers, and their service models. So, protocol layers, okay, let's talk about it. So this is a nice picture from the book, nice image. Basically, we have a ticket purchase. We have a baggage check, we have gates load, and we have runway takeoff. We have airplane routing, airplane. This is pretty much how the internet works. It just shows you the different protocols. All right, you purchase a ticket, you get the baggage on board, and there's the gates that you load, and you have to take the airplane has to take off, and the airplane has a route that it has to follow. And it goes back, does the same thing. It lands, goes to the gate, goes to the, and then you have to get your baggage, and ticket complain. That's so hilarious. Complain about the ticket. I'm gonna take a picture of this. This is hilarious. This is so funny. Hold on, I gotta post this. Oh man, that's so funny. Yep. Alright, sorry about that, a little bit of hiccup. Yeah, I'm just I had to look at this, it's very hilarious, concerning the ticket complaint. This is so funny. So don't forget to complain about your ticket. Oh man, this is hilarious. Network, so we're discussing about network. That's very hilarious. Alright, back to our work here. Sort of got it carried away a little bit. I think my music is too loud. Yeah, my music was way too loud. Anyways, so back to what we were talking about as far as network protocol. Let's see here. Let's continue with our so yeah. So yeah, it's pretty much like an airplane. We follow a protocol. It's the same thing with computers. A lot of the computer systems deal with real life. Looks like we have a 7. We also have a 7 OSI layer, but here the basic format is basically your application, transport, network link, and your physical. Those constitute basically the different layers of the protocol stack, which the computer must follow to be able to talk to each other. The first thing I'm going to go over with is the application layer. The application layer is for the the internet's application layer includes many protocols. So basically, we have applications of we have protocols in the application layer. One of them is HTTP, because as you know, it deals with the web. There's also SMTP, which is for email, and FTP, which is your deals with more your database systems, and that's kind of cool. I did not know that. And then you also have your DNS. And basically, it's the application layers has to be available, and it's a software. That's like I think about it. We have transport layer, which is TCP/UDP, and they basically what they do is they break long messages into shorter segments, so that they can. It's pretty much their congestion control. The UDP, unlike TCP, basically is a connectionless service to its application. So TCP has congestion control, and UDP doesn't have any control. It just sends message it might not receive. We do know that TCP is more used than UDP. I'll have to look at the different advantages of that. There's a couple. We do discuss it in other. I'll have to pull up the other PowerPoint to kind of look at what the advantages between UDP and TCP is. This constitutes the transport layer. Its goal is to basically two protocols for the internet. Let's see here, I'm not sure why it looks like that. Yeah, I think that's it. And we have the network layer. Network layer is basically responsible for moving network layer packets known as datagrams, okay, from one host to another. So basically it determines the address. Oh, okay, so the UDP provides the address. The transport layer kind of like determine the address, and the network layer is basically delivery. Okay, it's the one that can deliver to the destination. It's weird, I should have called this the transport layer. So one is known as your IP protocol. So your IP protocol, okay. So IP is the glue. Okay. Basically, this is the network. This is what allows us to talk to each other. It's a network layer. And you have the link, which can be your Ethernet cable, your Wi-Fi cable, even your Wi-Fi service. So you have your Ethernet, and you have all this cool stuff. All right. Let's see where we're at. Alright, so we have a physical layer now, and it's basically its job is to basically be the medium. We have copper wire, we also have fiber, they have different, we have coax. Alright man, I'm gonna get more soda, I'll be right back. OSI model. Oh, jeez. What is exactly the OSI model? What is that? It states that the OSI model took shape when the protocols were to become the internet protocols. The 7 layers of OSI are the application layer, the presentation layer, cool beans. Encapsulation shows the physical path that the data takes down settings and system protocol stack up and down. Routers and link layer switches are both packet switches. Existing routers and link layer are organized to networking hardware. So you can see that the application, I'll write that down. Here we can see that the source considers the application has the message, the transport layer has a segment, the network sends a datagram, and then link is the frame. Essentially, this is what the transport layer consists of, and we go into basically security, everything. Well, we go in depth of it goes more in depth with for example here each particular protocol has more detailed file transfer. HTTP belongs to your application layer, and then you have your DNS and how to program that. We have our transport layer. We have the transport layer again. If we look at the transport layer again, basically provides logical communication between processes running on different hosts. This goes more in depth. The transport layer provides logical rather than physical communication between application and process. We have UDP here. So basically, we will go more in depth with this different layers. For example, the transport layer. I think as far as we were in class, we were talking about UDP. It was our last one, and we talked about the IP network. The network itself. I'm gonna have to go through each layer actually. Basically, to go more in depth. That's gonna be another video, I think. So. We'll see. Network service models. So that's pretty much it, man. Let me just wrap it up. And basically, I was just going over some of the things. Like I said, we're gonna be looking at it. Basically, if we look at a summary. Here it looks like we can look at it here in order. We have the application layer, the transport layer, you have the network layer, the link layer, and you have the medium, which is your physical. So this constitutes basically the protocol, the network protocol stack. That pretty much concludes the video. Thank you for watching. If you have any questions, please feel free to drop in a comment. You can also join my Discord channel. It's active. If you just want to talk about this particular subjects. If you have any ideas as well, let me know. For anybody that sees this video, go ahead and post this on YouTube.